In our next couple examples, we're going to talk about exponential growth or exponential decay for non-nature based applications. Okay, our first formula we're going to be looking at is f of t is equal to a times b to the t, where f of t is our future value, a is the present or initial value, b is our base rate of change. But note, when our worth or amount is decreasing, b is going to be equal to 1 minus r, where r is the rate of decrease. And t is our time. So in this next example, it says a cell phone is purchased for $7.99 and loses 18% of its value every year. Cell phone's value can be modeled by the function v of t equal to a times b to the t. V is the dollar value, t is the number of years since purchased. Part A, express the value of the cell phone v after t years since purchased as a function of t. I know that totally sounded either Greek or like I was Charlie Brown's teacher going want, 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 want. So let's do what we did last time. Let's go ahead and label our variables off to the side, A, B, and T. Okay. They want us to have the value of the cell phone after years purchased. V is the dollar value, so that is our value. We're going to leave it because when we have our equations, or when we have our functions, not equations, but when we have our functions, you have to have two variables. The independent variable, normally x or t, and your dependent variable, f of x, f of t, or in this case, v of t. T is going to be our number of years since the purchase. So they better have told us what A and B are. When we're looking at the problem, they say that we purchased it for $7.99. Remember, A is our initial value, where the principal value or how much we originally paid, which means that A is going to be equal to $7.99. They tell us that the phone loses 18% of its value each year. And since it loses 18%, we need to take 1 minus 18%, which is 1 minus 0.18, and we get 0.82, which means we're ready for our function. We're going to have v of t equal to, we said A was $7.99 times our base B of 0.82 raised to the t. And this is the function we are going to be using to answer any future questions. Keep in mind, we can't multiply the $7.99 and the 0.82 because that 0.82 is taken to the exponent where the $7.99 is not. They want to know in how many years will the computer be worth half of its original value. If they're asking for how many years, they're asking us to find t, which means they must have told us what v of t was. They said half of its original value. Half of the original value will be v of t, but that means we need to take 1/2 times $7.99. You could leave it as $7.99 over 2 if you would like. Otherwise, if you want to use the decimal, you can have it as 399.5. And we're going to plug it into our formula. So we're going to have 799 times 0.82 to the t is equal to our v of t, which was our 399.5. When we solve this, we have an exponential equation, which means we need to get the exponential piece by itself before we do anything else. So we're going to divide both sides by the 799. When we do that, we get 0.82 raised to the t equal to 1/2. We have an exponential equation, and we know it's an exponential equation because our variable is being held hostage in the exponent. And to get that exponent down front, because we cannot rewrite 0.82 and 1/2 to have the same base raised to a power, we need to use a log. Because our base is 0.82, you have two options. You can either use log or natural log. Either one is fine. If it was base 10, we would use common log. If it was base E, we would use natural log. Here, doesn't matter, you can use whichever one you want. Typically, I like natural log, but this time I'll use regular log. Just so if you're watching my other videos, you are seeing that we have multiple ways to these problems. Does not matter which log you use, even though you will wind up having a preference. Because we have log of both sides, log properties tell us that that exponent comes down front as a coefficient, meaning that we have t log of 0.82 equal to log of 1/2. We need to get t by itself. Remember that log is just a number. Log of a number is a number. So we're going to divide both sides by log of 0.82. Those logs do not cancel out, but we find out that t is equal to log of 1/2 all over log of 0.82. And although this is our exact answer, they asked us for the decimal approximation, which means that you are going to need to use your calculator, which is part of the reason that we used just regular log or natural log, whichever one you did. But you need to take log of 1/2, and then you're going to divide that by our log of 0.82 or 0.82, get you the same thing. You should be getting t equal 3.4927886. But they wanted us to round to one decimal place. So we look at our second decimal, that 9 is enough to round us up. And we find that in 3.5 years, our phone is worth half of its price. Some of us aren't even done paying it off then. Okay. If you are asked to explain what you just found, the ordered pair we just found will be in the form t comma v of t, which means that you would have 3.5 comma 39.95, what you plugged in for v of t. If you're asked for an explanation sentence, you can explain this pretty much however you want, but there are a couple of things that you have to include. First, you have to include that we have 3.5 years. And then you have to include that the phone will be worth $399.50. So one way that you could say it is the phone, oh, sorry, not phone, the computer will be worth half its original price after 3.5 years. That's using exactly what they asked us in the question. The other way that I would tend to do it is after 3.5 years, the computer is worth $399.50. Just remember, when you write the money, it has to go to 2 decimal places. Let's look at another example. In example number 3, we have polluted water passing through a series of filters. Each filter removes 64% of the remaining impurities from the water. So we're doing a decrease. If you originally have 7 million particles of pollutant per gallon, how much pollution will you have after 2 passes through the filters? Because this is not a nature-based application, man has something to do with it. When we do our function, f of t equal to a times b to the t, we are going to have f of t as the pollution after t passes. We originally had 7 million particles, so that's going to be A. B is our base amount, but since we're removing, we're going to have 1 minus 0.64, which was our 64%, to get 0.36. And T is going to be the number of times we go through the filter. So we use the original equation that we discussed at the beginning of this video. We found the original amount, we found our base amount, and we subtracted it from 1 because we are removing, we are decaying, we are decreasing. Okay. And T is our independent variable, number of times through the filter, and f of t is our dependent variable because the amount of pollution depends on how many times we've pushed the water through the filter. So let's go ahead and finish writing out our function. We're going to have f of t is equal to 7 times 0.036 to the t. The question now asks, how much will we have after 2 passes? So that tells us that t is equal to 2. We need to find f of 2, which means we're going to have 7 times 0.36 to the second. Remember that the 7 is not taken to the exponent, only the 0.36 is taken to the second, which means that you should be getting 0.9072. And let's see, what do we want to practice rounding to? Let's go ahead and practice rounding to the nearest hundredth. So nearest hundredth, there are 2 zeros in 100, which means we're going to round to 2 decimal places. We look at the third, the 7 is enough to round us up, and we get 0.91. Keep in mind that if you were doing this for your job, you just can't go up to your boss and go, the answer is 0.91. They will have no idea what you mean. So let's talk about explaining what we just found. We just found when T is 2, so if the water goes through the filter twice, which is what they were asking us to find, how much pollution would be left. So there will be 0.91. And for our units, we have to go back to how they explained the original, the A, the 7 million particles of pollutant per gallon. So back here, we're going to have 0.91 million particles of pollutant per gallon. If you were asked for the ordered pair, our ordered pair would be 2, because we plugged that in for T, and we got out 0.91.